Good afternoon, YouTube. Needlebender785 Ohio with an LDMOS repair, but that's not super interesting, but more of an update and kind of if somebody watched my previous video, I said that I've got some new equipment that's going to be used in testing, not just I've had a spectrum analyzer for a couple of years, and I've been showing what the harmonics look like in all of my amplifiers. How I always wanted to strive to have the cleanest output. And when we talk about harmonics, we always talking about transmitting on other bands, transmitting on other frequencies. We always want to transmit on the frequency that we're transmitting and minimize our transmission down the road on anything other than our principal frequency. And the LDMOS, these devices demonstrated a phenomenal cleanliness on how clean they are. The third harmonic was, I think, 50, close to 55 dB down from principal, which is way exceeds any kind of standard. But there's another type of distortion that a lot of people don't talk about, especially in the CB world. In the ham world, it is talked about, but especially guys that care about their audio. So what we talk about here, what we're here to talk about today is intermodulation distortion. Now, if you watched my last video, I did a intermodulation distortion test on my own personal 3CX3000. I was able to demonstrate 34 dB down on the third, well, if you want to call it harmonic of the two-tone test. Now, that is actually exceptional quality SSB signal. Fantastic, because the standard, anything over 30 is just phenomenal quality audio. And we're going to do the same test today, but as you can probably see, there's a spoiler alert. It's not going to have very good results. And again, I'm testing my own product here, and you've probably seen that I've kind of transitioned away from making these LDMOSs to more of a tube amplifiers. Personally, I like working with tubes. I enjoy working with tubes. I like building tubes, and they work better in pretty much every aspect of this stuff. But I did make these for a while. They work great. I use one in my own personal truck, and it sounds pretty good. I mean, I get good comments on the audio. But here we're going to talk about the output. So this thing is rated about 1800 watts. They'll go up to about 2000 on the peak there. I turn that off so we're not wasting power. So I did do an earlier test at absolute full power, and I'd use the ultra pure sound generator from my FTDX10 and the computer generated sound, so I eliminated any kind of noise and anything. That was absolutely ultra pure to dual tone signal. And as you can see, let's talk about the positives of this wave first. So, I mean, those of you who know what you're looking at, you can tell that this is a pretty horrible wave, but not in every way. One thing that this wave does not have is crossover distortion. That's a lot of your harmonics are caused by poor biasing. So this thing is biased perfectly. As you can tell, that crossover, that sine wave is basically continued. One sine wave goes the other way, one goes the one way, and we can even zoom in here. You can see how perfect that crossover is. So there is no biasing problem in this amplifier. It's perfect, absolutely perfect. But if you look at the top of that and the bottom of that wave, you can see there's quite a bit of flat topping going on there, and that's actually that just distorts your audio quality, and does make your signal go bleed over on the other adjacent channels just a little bit there, and that's what happens. Your signal is kind of wide at the bottom, and guys next door will tell you that you're transmitting on one channel up and one channel down at the same time. We can hear you. And that's what we call intermodulation distortion. Now, not to be confused with harmonics. This is nothing. You're not transmitting on other bands. We're not talking about that. This amplifier actually has fantastic as far as harmonics. But this is IMD. This is your signal quality. This is how good your audio is and stuff like that, how wide your signal is. So as you can see, I mean, I've seen worse out of my Striker, but this is not very good. Like I said, the biasing is excellent. You can see that by the little crossover points. A very good biasing, but there's some flat topping. So in this video, we're going to try to fix this a little bit by reducing the power on this from full power. This is at 2,000 watts. So we're going to move over here a little bit, and you can see actual numbers. This is where you actually measure stuff. So I have the two prominent peaks there. I have the peak at let's actually recalibrate this a little bit. So we're going to take a look at the peak, and we're going to take a look at the marker. We're going to do delta, and we're going to go to this peak, because those are the most closest. You want to measure the worst possible. And again, that's exactly the same as the last one, so that we didn't really gain anything. So as you can see, 18 dB down. That is not very good performance at all. So those are your two principal signals right there. That's your 700, that's your 1900, since we're on lower sideband. Our center carrier is around here somewhere, and this is where we would be transmitting. So if you go 1.4, so let's do another marker here. So if you let's see, peak. So if we would go, let's say, on 27,385, so if we would go measure, we know this this peak is let's see, 1900 hertz from the frequency of from the center frequency, which is about here. So if we go here, we go another 1,000, so 1,100 right here. Let's go 1,100. So this would be our end of the band right there. So so we're technically a little bit outside right there, outside the band right there, and we're within 18 dB. So, and the band, this one is fine. This one's well within tolerance, and this one's 30. That's actually, that's, like I said, I gotta say, that's pretty poor performance when it comes to intermodulation distortion. And so now we're gonna see what it takes to get this signal in better shape. So let's plug this back in here, and let's reset this. We're going to turn on our bias so the amp will be keyed up. We're going to go into here, and we're using our software generated two tones. You can see those two tones right there. We're going to play them. We're going to put our PTT on, and we're going to turn down our power to 15 watts, and we're going to see if that hold it right there. Now we're going to put our signal generator into here, and then we're going to do sweep, and we're going to do our single sweep. There we go. And then we can stop our transmit and stop our audio. So we reduced our power by 5 watts on the input. And as you can see, let's go to peak, marker, delta. And let's do this one right here. Alright, so as you can see, we're 19.5 dB down. So that tells me we got to reduce the power quite a bit. So let's do, let's reduce the power. Let's do another 5 watts and see what happens. So right now we're at 19.2 dB down, which is still pretty poor performance, as you can see by the flat topping on top. So let's do that test one more time. We're going to take, this time we're going to reset this, and now we're going to turn on our peak meter and make sure we're not running a fan here. So okay, so let's alright, so now, and then look at the watts. We got 1500 watts. Alright, so now we stopped our transmit, and we do have to let this thing cool off a bit. Otherwise, we're going to have some very undesirable results. Okay, so now at 1500 watts, we're looking at a way better, I mean, it's not perfect, but it's way better two-tone signature right there. That was 1500 watts. So we lost 500 watts. And we're at 23 dB down. Let's actually recalibrate that. Peak marker, oops, peak marker delta. Yeah, same thing, 23 dB down, 22.84. So definitely better. I mean, so from 18 dB to 23, that's 5 dB. That's almost 4 times better performance. But again, not flawless yet. So I'm thinking we get about, I don't know, about 1200 watts. We might be getting, but this is way better. This is a lot better signal. And as you can see, it's a lot better. But again, not perfect, but way better. Again, the crossover still looks perfect, and we're just trying to work on our flat topping here. So 23 dB down on that two-tone generator. And well, like I said, we're not going to do any more testing until this thing cools off. But as you can see, most people are not going to get this device to run it at 1000 watts PEP, because that's what it would take pretty much to get probably your absolute best performance, because people want to get 2000, 2200 watts, and that's not really good performance when it comes to your audio quality. So just wanted to share that. And again, I'm testing my own amplifier, which I'm repairing at the moment for a customer. This guy just blew a pill. It's a 2-pill unit. We replaced the pill, and I got one section hooked up right now, the one I replaced, because I always test each section individually before I combine it, just make sure we got any kind of mismatch going on. So just testing this one particular section, and just thought I'd make a video, and why I'm trying to kind of distance myself from LDMOS. And I mean, it was a pretty good product. It still is. It works great. Sometimes it doesn't, but the signal quality is just not there compared to tubes. And like I said, I did a video of a two-tone signal on my own tube amplifier, and this number right here on the right was 34. So that just shows you where our cleanliness of our tube amplifiers. And again, the signal there is not 100% perfect. There's some just kind of a wobble. There's no flat topping there, don't get me wrong. That's not what the issue with tubes is. It's just kind of a, there's just small, very small distortions. Again, no crossover, tube is biased properly, but again, this number was 34. It's another whole order of magnitude and then some. And these two outer ones were way down, another 12 dB down. So again, just wanted to share that with you, and kind of an educational / update on the LDMOS video. But again, thanks for watching, and there is going to be more videos where we're going to be testing everything with for quality, signal quality, and as well as RF signal quality and audio quality. So that's kind of my goal here, is not to promote, try to sell something. You know, I do sell stuff, but again, I just want to show you what the product does on the meters, and kind of go from there. Anyway, 73's, Needle Bender 785 Ohio. I'm back on the site.